Hello everyone, a very warm welcome to all of you. This is Singh. I'm a faculty in Applied Science Department, currently taking the subject Business Statistics in BCom. Here begins my lecture. The subject is Business Statistics, and the today topic which I'm going to cover in this whole video is Measure of Central Tendency, that is mean. This topic is Merits of Median. It is easy to compute and understand like mean. It is well defined and ideal average that should be. It can also be computed in case of frequency distribution with open-ended cases. If we have a cases like where the data set has open-ended continuous values, we easily can find the median even. It is not affected by extreme value and also interdependent of range or dispersion of the data. It can be determined graphically. Just looking at the graph, we can come to know where the median is. It is a proper average for qualitative data where items are not measured but scored. After merit, we have a few demerits as well as so we have a demerits of median. For computing median data set to be arranged in ascending or descending order. So it is a bit hard work that we have to do before we play with the data. We have to arrange in an order. Either it has to be in ascending or increasing or descending or in decreasing order. So that is a bit toil you have to do before you formulate the data set. It is not based on the all observation of the data, right? Yes. Simply if we know that yeah the frequency is 10, so we will just divide 10 by 2 and we will come to the fifth position. That will be the median. So it is a drawback that it is not based on all the observation of the data. It cannot be given further algebraic treatment. Once we get the median, we are not going to use the value in other statistical evaluation. It is affected by fluctuation of sampling. Yes, if we have a sample, let's say we have a sample size, we increase the sample size, the median is going to be changed. So it gets affected by increasing or decreasing of the sampling. It is not accurate when the data is not large. In some cases, median is determined approximately as a midpoint of two observations, where for mean this doesn't happen. Median. The median is the middle number in a sorted ascending or descending list of number can be more descriptive of that data set than an average. Median is sometimes used to oppose the mean when there are outliers in the sequence that might skew the average of the values. If there is an odd number, the median is number that is in middle and the same amount of number below and above. So median is basically an positional average. If we have an odd number of terms, we just go to the middle term. The middle term will be the median of whole data set. If there is an even amount of number in the list, the middle pair must be determined adding together and divided by 2 to find the median values. So we have an example of median. First, we have a individual data set. Suppose we have a following series 15, 19, 21, 7, 10, 33, 25, 18 and 5. And we have to find the median. So first we will arrange it in either ascending or descending order. These figures are arranged in ascending order as well as follows. 5, 7, 10, 15, 18, 19, 21, 25, 33 in ascending. Now as the series consists of odd number of items, to find out the value of the middle item, we use the formula n plus 1 by n plus 1 divided by 2, where n is the number of item. We have a 9, so then we will have 9 plus 1, that is 10 divided by 2, that is 5. So we will go to on fifth position. Whatever we will have in a fifth position, that will be the median of whole data set. So on the fifth position we have this, we have 18, hence the median will be 18. We have more example. Suppose we have the following series: 15, 19, 21, 7, 10, 33, 22, 25, 18, 5, 23, and we have to find the median. Again we will arrange it either in ascending or descending. Mostly we will arrange in ascending order. Now the series consists of even number. Now we have to find the median. In earlier question we have the series in odd number. Now we have the even number. Even number means we have a total number of terms which are 10. So the median formula will be n by 2 plus n by 2 plus 1th term divided by 2. Here n is 10, so fifth plus sixth term divided by 2, whatever comes. So the fifth term is 18. So 18 plus 19 divided by 2 is 18.5. Hence the median will be 18.5. Arithmetic median of discrete data series. So now we have to find the median of discrete when the value, we have a class or we have a frequency. We have a x, 10, 11, 12, 13, 14, and their frequencies are 3, 12, 18, 12, 3. So now we have to find the median. So first we will write x and f in a column. Then we will find the cumulative frequency just by adding all the successive frequency. The frequency first we have 3, we will write 3. The next one is 12, we will just add 12 to 3. It becomes 15. Continuously we will add on all the successive frequencies. So the final cumulative frequency we have is a 48, and the 48 will be the sum of the frequency as well. So the median will be the size of n plus 1 by 2 term. It means size of n plus 1. N plus 1, n is 48. The value of n means sum of frequency. Sum of frequency here is 48. So the value of capital N is 48. 48 plus 1 is 49. 49 divided by 2. It means we are going for the, we are going for 24 point something terms. So the 24 will come into this series. I mean it come after 15. It will come somewhere there. So it come there. So for which value it will come? It will come for the value of 12. Hence the median will be 12. Hence the 12 is the median. Now we have one more example of median in the case of continuous. Now the data is continuous. It means we have a continuous data series. The marks, we have a marks 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. And their frequencies are 7, 12, 18, 25, 16, 14, 8. We have to find the median. So first we have to find where the median lies. So the formula is size of n by 2th item. So here n is 100, 100 by 2 is 50th. So we have to go for the 50th item in our cumulative frequency. So the 50th item lies here. It means it will come after 37th. So we are talking about these interval 30 to 40. So the formula of median is L plus n by 2 minus CF divided by frequency into I. L is a lower limit, n where is n is the total number of frequency which is 100. CF the cumulative frequency of the previous one. F is the frequency of the current marks. I is the class size. So here we have L lower limit 30, n by 2 we have already 50, and cumulative frequency will be the previous one, that is 37, and it will be divided by the frequency of the current marks, that is 25, and will multiply by the 10. So the median is going to be 35.2. So already it is coming in this range, so we were not sure what the number it will be. So the the exact median is 35.2. We have one more example of continuous data series. We have to find the median of the following data. When the data is given, we have a marks 0 to 5, 5 to 10, 10 to 15, 15 to 20, 25 to 30, and 35 to 40, and their frequencies. So we will just apply the same formula. Median will be size of n by 2. Again, frequency here is 100. So the size of n by 2, that will be 50th item. So L 50th item will here lie will in between 30 to 55. So the interval will come, that will be 20 to 25. L will be 20. Now we have the topic correcting the incorrect mean. The average height of 10th student in a class of as 166. On verification, it was found that one reading was wrongly recorded as 160 instead of 150. Find the corrected mean height. So one question directly come from this topic, correcting the incorrect mean. We know the average height of 10th student is 166. So here's 166 is the incorrect mean for 10, the value of 10, value n equal to 10. So the formula mean is sum of x divided by n, sum of x divided by 10, sum of x will be equal to 1660. That will be multiplied 166 multiplied by 10. So the incorrect mean, so the incorrect and correct will be given by this. So what we will do, we will subtract the incorrect and add the correct value to the sum. So the incorrect value is 160 and the correct is 150. So hence 1660 minus 10 will be 1650. Now we divide it with 10. That's the total number of student. So correct arithmetic mean is 165. So now we got the correct arithmetic mean, which is 165. Another problem we have the median and mean here. The median is 52 and mean is 50. The value of largest item is 100. It was later found that it is 110. Now we have to find the true mean. Again we will apply the same formula. So the sum of x here is 5000. So sum of x, that is 5000. We will subtract 100 and add 110, and we will divide it with 100. We have 100 item, hence the value of n is 100. Hence the correct mean is 50.10. So hence the true or real mean value is 50.10. So that's all for the median. In the next lecture we will talk about mode. We'll see you in the next lecture.